This lesson is on our Learning Target 7 in Unit 1, inverse functions. The question we're going to try to answer through this lesson is, how do you create an inverse function and evaluate it? So what's happening here between these two possible outcomes? Let's try plugging in a -3 into the f of x and plugging a -7 into the g of x. And let's find out what we get. So I plug in -3 into my f of x. Three times -3 is -9 plus 2. And this is equal to -7. So f of -3 is equal to -7. Let's try plugging a -7 into my g function. -7 minus 2 is -9. Divided by 3 is -3. So my g of -7 is -3. Well, that's an interesting outcome because in the f function, input was -3, output was -7. Over in g, input was -7, output is -3. My inputs and my outputs are reversed for these two scenarios. That is what an inverse function really is. So what's an inverse function? The inverse of a function is kind of like switching around a table of values, because we just saw that an inverse is the input and the output switched around, and a table of values is an input and an output. So here's a table of values for a function: -2, 4, -1, 1, 2, -2, 1, -5, and 2, -8. All we have to do to create an inverse is to switch our x's or y's, switch our inputs and our outputs. So what will we get? Well, the -2, which was an x, is now a y, and our 4, which was a y, is now an x. -1 is now the y, and 1 is the x. 0 is now the y, and -2, 1, -5, and 2, and the -8 moves up to our x's. Let's take each of these tables and let's put them into Desmos and take a look at what they look like. Because tables, they can make graphs, and should be helpful to take a look at what these tables actually look like when they're graphed. Here in Desmos, what we're going to do is we're going to go to the plus sign and we're going to say add an item. We're going to add a table. So let's make our first table. Our first point in our table was -2, and then we had -1, 0, 1, 2. And our y's were 4, 1, -2, -5, and -8. And we are going to tell it to connect the dots. Here we go. So there is our line, nice and graphed. Let's go add a new item, add a new table. This time we're going to switch around those x's and y's. So here we now have -2, -1, 0, 1, 2. X's have become y's, and our x's are now 4, 1, -2, -5, and -8. And let's connect those dots. There we go. So this is what inverse functions look like when they're graphed. It's almost like they've been flipped over and now they're pointing in a slightly different direction. So how do you find an inverse function? Well, we saw that the inputs and outputs switch around. We saw that on a table, the x's and the y's switch around. So I think that's what you should do. Step one is to switch the x and the y around in a function. Once you do that, you need to make it say y equals again. You need to solve for y and get y alone. So here's our first example. Let's take a look at this. We're going to switch our x and our y around so that now it's going to say x equals 2y plus 1. We're going to try to get that y alone. That doesn't mean just switch right back, because then you haven't really done anything. What we're going to do is we're going to undo all the things happening over here where the y is. First off, there is a plus 1. We need to get rid of that first before we can get to the 2 next to the y. So we do that by subtracting 1 from both sides. I end up with x minus 1 equals 2y. And now in order to get the y alone, which has a 2 being multiplied to it, let's divide by 2, because that's the opposite of 2 times. And I end up with something that says this. X minus 1 over 2 equals y. You can switch that around so that it says y equals x minus 1 divided by 2. So this is the inverse function of what I started with. Be very aware that everything I see happening in the original function, 2 times x plus 1, is the opposite in my inverse. It was times 2, now the inverse says divide by 2. It said plus 1, now the inverse has minus 1. Also, you have to do things backwards. In my original, I would have to multiply first, then add. In my inverse, I subtract first, then I divide. So not only are the operations backwards, but also the order is backwards on top of that. So what about f of x? You know, sometimes functions are written that way. They're not always written with a y in the front of it. Sometimes they're written with an f of x in the front of it. Well, remember that f of x means output. And so does y. So you're allowed to just turn the f of x into a y to continue. So then you can switch the x's and the y's around. Although when you write your final answer, there is a very particular way to write the final answer. If the function said f of x, then when you create that inverse, you're going to write it this way, with an f with a little -1 and x. So that little -1 right there, that means inverse. One last example, just to make sure we got these steps down. So we're going to change our f of x, that's right, into a y, so that we can do our switching around of x's and y's. Now let's switch our x and y around. So it's going to say x equals 3 divided by y plus 1 plus 2. Now let's start to undo these things. I don't think I can get near the bottom, that y, because it has that plus 1, but it's also being divided with 3 above it, and there's a plus 2, so I think the plus 2 comes first. So we're going to subtract 2 both sides. X minus 2 equals 3 over y plus 1. Now this is a little tricky here. I have a y plus 1. That is what's being divided. It does not say divide by 3. I cannot multiply by 3. Again, the problem right now does not say divide by 3, so I cannot multiply by 3. So what I'm going to have to do here is I'm going to have to put this over a 1. Okay. This way, I can multiply this side by the denominator, which is a y plus a 1. And I can multiply this side by that y plus a 1. So these cancel out. It is no longer on the bottom of our problem. Let's rewrite what we have so far. I'm not going to actually do any multiplying. Let's just rewrite. I have a y plus a 1. I have an x minus a 2. And this side is left a 3. Now, if I want that x minus 2 to go away, parenthesis to parenthesis means multiply, so let's divide it. There we go. So now they can go away. What am I left with? I'm left with an y plus a 1 equals a 3 over x minus 2. I still have to get rid of that negative, that positive 1 with a negative 1. So I'm going to subtract 1 to both sides. And so my answer is y equals 3 over x minus 2 minus 1. But don't forget to turn that into our better way of writing inverse. F of x with a little negative 1 is equal to 3 over x minus 2 minus 1. So this is the way we're going to write our final answer. So a lot of this stuff is pretty much messing around with undoing operations, making sure we're following order of operations, and switching x and y. Again, if you're going to take anything home, really understand and remember something super important for the rest of the year about inverse is you switch x and y. Always switch x and y and make an inverse. You switch your inputs and outputs. That's key, okay? You switch your inputs and outputs. If you want to have an inverse, switch x and y. All right. If you have questions, make sure you write them down and you bring them in the class.